In our journey so far together, you and I have taken a look at several implementations of IPv6. Fairly early on in DNS and DHCP, it's also been present in many of our other nuggets as well. In this video, I'd like to focus on some basic concepts regarding IPv6 and also give you some pointers on where you can go if you'd like to take a very deep dive into the world of IPv6. IPv6 addressing, which we've been told is going to catch on someday, has been around for over a decade. And although it's being used a little bit more, it is still not the dominant protocol on the internet. IPv4 still is. And one of the cool things about IPv6 is that we can leverage a lot of our knowledge of IPv4 as we apply it to IPv6. For example, IPv6 represents a binary number, except it's 128 bits in length compared to 32 bits. And because it's not very practical for us humans to put in a lot of ones and zeros in that fashion, instead of using binary to represent it, we're going to use hexadecimal. So in IPv4, we use decimal, and in IPv6, we use hexadecimal. For example, an IPv6 may look like this. So let's break this down. First of all, we're using hexadecimal characters. So in binary, we have 0 and 1. In decimal, we have 0 through 9. And in hexadecimal, we have 0 through F, which is 16 unique characters. So with hexadecimal, it looks a lot like decimal until you get past 9. Then once you get past 9, it goes A, B, C, D, E, F. And so the decimal equivalent of those is 10, 11, 12, 13, 14, 15. So in an IPv6 address with hexadecimal, each hex character represents 4 bits, and it's pretty easy to break down. To convert hexadecimal, all we need is 8, 4, 2, 1. That's our key, that's our chart, if you will. And every hex character represents 4 bits. So for example, a 2 would be 0, 0, 1, 0, using our lessons we learned in binary from our IPv4 studies. And if we go on to 0, that'd be 4 zeros, and this is 4 zeros, and the 1 would be 0, 0, 0, 1. And if we get to a character like D, which represents 13 in decimal, a 13 would be an 8, so we'd have a 1 in that position. We'd have a 1 in the 4 position, that's 12. We have a 0 in the 2 position and a 1 in the 1 position. So 1101 is a D in hexadecimal. So if we ever needed to do a conversion from hexadecimal into binary, we just do it 4 bits at a time. So to represent an IPv6 address, we use 8 groupings of 4 characters each. So each character represents 4 bits. Each grouping represents a total of 16 bits, and they're separated by colons. And there's 8 groups. So although it's a lot better than typing out 128 bits of zeros and ones, it's still pretty lengthy. So there's some shortcuts that we can take. For example, some of the shortcuts are that within a group like 0db8, if there's a leading 0, you can just leave it off. And the system will assume that those leading characters are zeros. So you don't have to literally put in leading zeros within a group. So for example, we could leave that one off. We could leave these 3 off. We could leave these 3 off and leave these 3 off. And leave this leading 0 off. And this system would be very comfortable with knowing exactly what we're talking about. So you don't have to put in leading zeros. Another shortcut that we can follow is that if we have 2 or more consecutive groups of zeros, like we do right here, I'll put those in green. Instead of typing those all in, we could do a colon, colon, back to back, instead of putting all those zeros in. And the system would know, okay, there's supposed to be 8 groups of numbers. I see 6. I see this colon, colon here in the IPv6 address. There must be 2 sets of all zeros at that spot. And we can use that trick 1 time per IPv6 address. You can't use it twice. For example, you can't use it here and here because the system wouldn't know whether it's 1 grouping here and 2 here or 2 groupings here and 1 here. And for globally routable IPv6 addresses, they have a range that begins with 2000 and it goes all the way to 3FFF. So anything that starts in that range is considered a globally routable address. So to play on the public internet, you'd be assigned by a provider or a registry a block of addresses to play in that could then be routable over the internet. Also, a client is likely to have more than just one IPv6 address. We've touched on these in our DHCP nuggets with IPv6. So don't be surprised to see 2 or more IPv6 globally routable addresses associated with the single interface on an IPv6 device. Now, besides globally routable addresses, there's also something called a link local address, and those start with FE80. That's what they look like. And they can use it to communicate with other devices in the same VLAN, or on the same segment, if you will, of the network. Also, with IPv6, we don't use a broadcast. Instead, we use multicast functionality. And multicast addresses always start with FF something for that first grouping of numbers. And if we don't want to manually assign IPv6 addresses to devices, we have several options. We've seen a couple of them in this course so far. One of them is to use DHCP. And if we configure a DHCP server, it can hand out an IPv6 address to a client as a lease. Another option is we can have a server send out a router advertisement, as well as respond to a client who's sending a router solicitation. And in that router advertisement, we can advertise what the prefix is. For example, we can advertise the 64-bit network of 2001 DB867830 with a 64-bit mask. And then the client, after identifying the network it's connected to, based on the router advertisement, can go ahead and calculate a host address with the last 64 bits, verify that it's not being used by some other device on that same network, and then start using that as an IPv6 globally routable address. And if we want a Windows 2016 Server 2 route for IPv6, we just go into the properties of routing and remote access and make sure that we have IPv6 addresses on the interfaces of that device. And we've also checked the box that says we want to enable routing for IPv6. So in our lab environment, let's go take a look at our client and Server 2 just to confirm a few of those details in the interface. And you can follow right along in the hands-on lab. So let's begin here on our Windows client. Let's go to the network properties. We'll right-click on the Windows icon, bottom left-hand corner, and select Network Connections. From here, let me go ahead and disable our outside 23 network just for a moment. So we'll right-click on outside 23, and from the menu select Disable. So now we just have one active interface connected to the corporate network. So let's open up the properties of that. We'll right-click on Inside 192, and from the drop-down, click on Properties. From here, we'll double-click on Internet Protocol 6 to bring up the properties for IPv6, and currently it has a statically configured IPv6 address. So if we wanted to put in the full IPv6 address, we could. So I've added the leading zeros and the consecutive zeros, and I've also specified the mask is 64 bits in length. So the mask works identically as it does in IPv4. It identifies how much of this IPv6 address is going to be used for the network, and what the mask doesn't take is left over for host addressing. So here with the 64-bit split, it's half and half. The left half is the network address, and the right half is host addressing. And I'm not going to specify a default gateway. And down here it has the DNS servers. So if we click on OK, and let's click on OK to save those changes, and let's go back to PowerShell. So here in PowerShell, if we use the get net IP configuration command again with it highlighted, we'll hit F8. Notice that even though we put in the leading zeros and the consecutive zeros, it used the shortcuts. It took out the leading zero in front of DB8, and it used the double colon before the 120 to represent consecutive groups of zeros. So let's minimize this for a moment. Let's go back to the properties of the inside interface by right-clicking, going to Properties, and double-clicking once again on IPv6. If we wanted to have it get an IPv6 address automatically, as well as DNS information automatically, we've got some choices. Now, from a previous nugget, many nuggets ago, we set up DHCP for IPv6. Also, we have some routing and remote access for IPv6 in place where the router is advertising the network address. So there's two different methods this client could use to go ahead and determine what the network it's connected to is. One through DHCP and the other through the router advertisement, at which point it could use SLAAC, which is an acronym for Stateless Address Auto Configuration. So if we go ahead and say do it automatically and click on OK, and click on OK again, and then bring back our PowerShell environment, and we'll clear off the bottom part and run that get net IP configuration command again. So now it's using this IP address for IPv6, and the involved parties regarding that could be DHCP or the router advertisements. And to get even more information on that, we could use a get-net IP address space, and let's go ahead and just narrow it down to IPv6. We'll use the -address family option space -IPv6, and then with the cursor at the end of that row, we'll hit F8. Then we'll scroll up a little bit in the output here. And this provides us even more information. Here's the link local address that this computer is using, or can use on the local network. Here's its globally routable address. If we scroll down a little bit in the output, it also indicates where the prefix came from, prefix origin, and it's coming from a router advertisement, which means we have at least one device on our network. Maybe it's a router, maybe it's a Windows 2016 server with routing and remote access running, who is responding to router solicitations as well as periodically injecting router advertisements onto the network. To verify that, let's go take a road trip over to Server 2 in the lab environment. So here on Server 2, let's expand Server Manager full screen. And let's go to Tools, and from the drop-down, let's go to Routing and Remote Access. If we click on server 2-nug and then right click and from the drop down go to properties, on the general tab, it indicates that it's doing routing for both IPv4 and IPv6. That's great. If we click on the IPv6 tab, here we have checkboxes for enable IPv6 forwarding as well as enable default route advertisement. And in that router advertisement, it's going to advertise 2001 DB86783::, and the ::: represents one or more consecutive groups of zeros following. So we'll click on cancel to close the properties of server 2-nug. And if we wanted to verify that IPv6 routing was functioning, what we could do is we could right click here on server 2, right click on the Windows icon, bottom left hand corner, and from the menu select network connections. And from here, let's click on the 10_net. It's disabled at the moment. Let's right click on it and then select enable. And then with it enabled, let's right click on it one more time and go to properties. And then let's check on the box to enable IPv6 on that interface. And we'll double click on IPv6 as well to look at the properties of IPv6 on this interface. So let's go ahead and assign an IPv6 address of 2001:ABC::120 with a 64-bit mask. And we'll click on OK. It's warning us about DNS. I'm OK with that. And we'll click on OK one more time. And as I think about that, that's not the IP address I want to use. I want to use 102. We're going to keep that last number the same. So we'll go back to the properties of that interface. We'll double click on IPv6 and let's change that to 102. And that way all the interfaces for all the protocols on server 2 end in 102. And we'll click on OK, OK, and OK. Fantastic. So let's go back to our client and see if we can reach that IPv6 address. So here at our client, let's go ahead and do a getnet IP configuration just to remind myself of where we're at. And we do not have an IPv6 default gateway. So this client's not going to be too helpful in forwarding a packet in the direction of server 2. So let's go ahead and modify the properties of IPv6 on the client. So here at the client, we'll right click on inside 192, go to properties, double click on IPv6, and let's manually assign the IPv6 address, and we'll also put in a default gateway. We also, optionally, pun intended, we could go to the DHCP server and hand out the IP address via IPv6 from the scope and assign an option that includes the default gateway for the client to use. But since we're right here, we'll statically put in the IP address of 2001 DB86783::120, 64-bit mask with the default gateway of server 2's address, which is 2001:DB86783::102. And we'll click on OK, and OK again. So now let's go back to our PowerShell scripting environment. So here we can do a ping or a testnet connection and verify our connectivity. So let's try that right here. And that address is 2001 ABC 102. Now for that to work, routing for IPv6 would have to be enabled on server 2, and our client would need to know to forward over in that direction. And because of the default gateway we just set up for IPv6, it does. So let's go ahead and with row 3 highlighted, we'll hit F8 and we'll test that. And that indeed is working. And if we do a test-net connection to that same address, I'm just going to copy and paste that onto the next line with a Control-C and a Control-V. Then we'll highlight row number 4 and execute that. That also confirms that it worked. It also confirmed what interface we used, which is our inside 192, as well as the source IP address that we used to go ahead and forward that packet. The last thing I'd like to do in this nugget is chat with you about where you can go for more information, a deeper dive into the world of IPv6. And one of the best resources for that is the IPv6 course right here at CBT Nuggets. In fact, I would invite you to take a look at maybe the first 3 or 4 nuggets in that course to reinforce some of the concepts we've covered right here in this nugget. And then for those of you who want to go on and deeper regarding IPv6 and the protocols it uses and network discovery, please feel free to enjoy that course as an excellent tool to take a very deep dive in the world of IPv6. So I'll leave that choice in your capable hands. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.